So in this video, we're going to continue talking about triangles. We've learned some helpful theorems to prove that pairs of triangles are congruent. And what I want to talk about in this video is taking advantage of the theorems that help us show triangles are congruent to show that pieces of triangles are congruent. All right, specifically angles and line segments. Now, it might seem a little ironic, but sometimes it's actually easier to show that triangles are congruent than it is to show that angles or line segments are congruent. All right, or maybe a better way to say it is it's sometimes easier to prove pairs of angles and line segments are congruent by first focusing on triangles. All right, so let's do an example and I'll show you the reasoning. I'll show you why that is the case. Suppose that we had an isosceles triangle. All right, and that means that two sides are congruent. So let me go ahead and mark two of the sides with our congruency marks. Now, what I want to show, I want to prove that the bottom angles, what are referred to as the base angles, are congruent. So prove the base angles of an isosceles triangle are congruent. All right, so how would we prove that those angles are congruent? Well, let me show you how using our triangle skills will help. So let's first draw a median from the top, what's known as the vertex, to the opposite side. All right, and if it's a median, we know that that means that it's going to split the opposite segment, the bottom segment, into two congruent pieces. So I'll put the congruent marks there. Okay, so notice that I've divided this triangle into two smaller triangles. Okay, notice, let's call them triangles A and B. I also can be sure that those are congruent triangles. Why? I can use the SSS theorem. Okay, they share the vertical side. Okay, so that's one S. The red marks show the second S pair, and then the blue congruency marks show the third S pair. So that's all well and good, but how does that help us regarding base angles? Okay, remember, what does it mean to say that two triangles are congruent? It means they have the same size and shape. Okay, keep going. What else does it mean? It means that the corresponding line segments and angles are congruent. Okay, let me repeat that last part. The corresponding line segments and angles are congruent. So that means when we compare the corresponding angles between A and B, we know that, well, those are corresponding, so they have to be congruent. The angles at the top are corresponding, so they have to be congruent. And then all the corresponding pairs of angles are congruent. All right? So notice that that completed our proof. Okay? So SSS showed that the two triangles that we divided the isosceles triangle into are congruent. And then we use that to show that the desired angles are congruent. Okay? This idea of that congruent parts of congruent triangles are congruent, we use this idea so much in proofs that we actually refer to it by the acronym, okay? CPCTC, CPTC. Congruent parts of congruent triangles are congruent. Okay, so I used CPTC after I used the SSS theorem to do this proof. All right? Now, let's do another proof using CPTC. To use our new acronym. All right? This time, I want to show that if you have an isosceles triangle and you draw a median from the vertex angle, from the vertex, the vertex between the congruent sides, that it's also always an angle bisector. Okay, so let me put all that down. So we'll start with the triangle. And we will draw a median from the top. Okay, and so what we're doing is proving the following. So prove the median of the isosceles triangle is also an angle bisector. All right, so we know that to be an angle bisector, that means that the blue median divided an angle in half. So at the top, that it's chopping the angle in half into two congruent angles. All right, so we're going to use Kiptich, so let's go back to basics. An isosceles triangle means that it has two sides that are congruent. Because the blue stick is a median, it chopped the bottom line segment in half. So those two pieces are congruent. All right, so again we can use SSS to show that triangles A and B are congruent. And then by Kiptich, we know that the corresponding angles are congruent. Therefore, the median must also be an angle bisector. Okay? Now, another proof you could also do is show that this median must also be an altitude. Okay? And the proof would basically be along the same line as this one. We prove that the two smaller triangles are congruent, and then Kiptich, in this case, Kiptich, we know Kiptich shows that at the bottom where the blue stick meets the opposite side, the one that's divided in half, we know that the angle there, we know that the median forms forms a congruent angle pair. All right. The only way that a straight angle can be divided into two congruent angles is if those angles are right angles. Okay? So therefore, those angles there, I'll put the right angle symbol. Okay, those are right angles, and therefore the blue median is also an altitude. Okay? Now, you can also use Kiptich to show that equilateral triangles must also be equiangular. All right, let me discuss that now. So I'm doing several examples, hoping that this will get you used to seeing how to use Kiptich. Okay, so if I had an equilateral triangle, that means all of these sides are congruent. All right, does that mean that the angles are congruent? All right, well, suppose that we drew a median. All right, we're clearly going to use Kiptich here. So what we're going to do is we're going to draw a median, and so that means that the bottom is chopped into two congruent pieces, and therefore we have SSS to show that the two smaller triangles are congruent, and therefore we know that the corresponding angles are congruent. So that gives us that these bottom angles are congruent. Okay, now you also could have taken advantage of the fact that we just proved that isosceles triangles have base angles congruent, and an equilateral triangle is clearly isosceles. It clearly has two congruent sides. So I just basically repeated the proof that we did for the isosceles triangle when we proved that the base angles were congruent. But anyways, so that would give you those two are congruent. Now you could redo the reasoning the analysis that we did with a different median. You can draw a median this way now, okay? And that would give you that another two pairs of angles are congruent. Okay, that would give you that these two pairs of angles are congruent. These two specifically. Okay, and so we first proved that these two pairs were congruent. Now we have another two pairs, and so that clearly means that these are congruent. So all three must be the same. So we've just shown that an equilateral triangle is also equiangular. Okay, now the examples that I just showed you, all of them were used to show that certain angles were congruent. All right, you can also use Kiptich to show that line segments are congruent. So let me show you an example of that now. Suppose that we had two upside down ice cream cones or two upside down triangles. Maybe that's some shape somebody painted on a canvas, whatever. Okay? And suppose somehow we knew that these sticks were congruent, and we also knew that the bottom was, that angle on both was 30 degrees. And let's say we also knew that we had 40-degree angles on each of them. All right, so that's all well and good, but is the top line segment, are the top line segments congruent? All right, you could take a ruler and measure them to see that if they were congruent. However, the measurements you've already done to measure the two angle sizes and the other corresponding line segments, that's good enough. All right, why is that good enough to establish beyond a shadow of a doubt that the horizontal line segments are congruent? Well, can you see that the two triangles must be congruent? All right, why must the two triangles be congruent? Can you see why? So they have a congruent angle pair, they have another congruent angle pair, and right between them they have a congruent pair of sides. Okay, so ASA establishes that both of these triangles are the same, and then Kiptich establishes that all the corresponding angles and sides are the same. So clearly it's going to establish that the pair that we want is also congruent.